Question number 1, the graph of f at x is transformed to the graph of g of x. So you can see that it's a transformation of f because it has f in it when you look at the equation for g. So the equation representing g. All right, so if we look at our parameters that are in g, the one thing you have to again recognize is that b is not taken out as a common factor. There's a negative sign in front of x, which means b is -1. Remember, to get the true h value, b and x minus h must be separated by brackets. And that is done by taking out a common factor. So that would be the first thing that we would need to do. And that would give you x plus 5 inside the brackets. So a is +2. That means it's a vertical stretch by a factor of 2. You might remember that when we add an a parameter onto an existing equation, you have to multiply the entire equation by a. It's a times f at x. The entire equation gets multiplied by a. So f at x would be found by multiplying the entire equation by a. And that function basically has two terms. The first term is 8 bracket x plus 2 all squared. The second term is -3. So in this case here, it'll become 16 bracket x plus 2 all squared minus 6. So that's just the first step. That's dealing with an a value of 2. A is multiplied by f at x. The entire function gets multiplied by a. And that original function has two terms. That first term has two factors, 8 and x plus 2 all squared, but it's all part of the one term. So it just gets multiplied by the 8. So then we have our next parameter, which is our b equaling -1. And that's done by replacing x with -x. So in this equation, we replace the x with -x. So now we'll have f at x equaling 16 times -x plus 2 all squared minus 6. When b is negative, you replace x with -x. And then the last transformation that we have to do is that the x is replaced with x plus 5. That's an h value of -5. The graph is going to go 5 units to the left because h is -5, which means we're going to subtract 5 from this x plus 2. So it'll be f at x equals 16 bracket -x minus 3 all squared minus 6. Okay? Now, again, here's where that -3 comes from, right? If we go back up to this previous equation, that is the equation. But the h value is actually not +2. It would be -2, because to get the correct h value for this equation, and I probably should have done that, just so it's 100% clear what's going on here. Once again, b must be taken out as a common factor. I kind of ran out of room for that -6 at the end, but to get the true h value from this step in the equation, again, b must be taken out as a common factor. So that tells us our h value is actually +2, and then if you go 5 to the left, it'll become -3. And you see, if you take out the b value out of this, you'll get an h value of -3. I probably should have done that at the start, especially in this step here, taking out the -1 to get the true h value so that we can shift it 5 to the left. But either way, our answer is C. Right, that's in this form here, whereas we also wrote it with the -1 in front as a common factor to see what the true h value was. So either way, that's your equation. Number 2, same type of question. You're starting with f at x, and g is a transformation of f. The coordinates 3, -1 on the graph, then the coordinates 3, -1 on the graph of y equals g at x will be what? So this is saying that the point 3, -1 is on the original graph. And you could see that if you let x equal 3, 2 times 3 is 6, plus 3 is 9, square root of that is 3, take away 4 gives you the -1. So what will that point become after that transformation? Well, again, you've got the negative in front, so that's going to do something. But we can't forget, once again, that the b value must be taken out as a common factor to get the true h value. So if we were to write a mapping notation to go from f to g, you've got a b value of 2, which will be a horizontal stretch by a half. The x values will get multiplied by a half. You've got an h value of -3. So that means it's going to go 3 to the left, or you're going to subtract 3 from the x values. The y values we multiply by -1 because a is -1, and then decrease by 1 because you have the -1 at the end. So there's the mapping notation for that. Right? So if we take the point 3, -1, so the x values are multiplied by half. Half of 3 is 3 over 2. Take away 3, which would be 6 halves. That would give us -3 halves, or -1.5 for an x value. Our y value is multiplied by -1, so -1 times -1 is +1, and then that needs to be decreased by 1 to give us 0. So that's why A is the correct answer for that one. Okay? This next question we use that information for. We want to find the vertical and horizontal asymptotes. They're represented by the information in which row. Let's start with the horizontal asymptote. That's probably the easiest. The degree of the top and bottom is the same, and when that happens, to get the horizontal asymptote, you divide the coefficients. So y will equal the coefficient of the x squared on top is 2 over the coefficient of the x squared on the bottom is 1. So y equals 2 will be the equation of the horizontal asymptote. So based on that alone, we can cross off B and C. But now we have to find the vertical asymptote. And we do that by simplifying the expression, by factoring. On the bottom, the factors are x minus 4, x plus 1. Excuse me. And if we put an x minus 4 there and a 2x plus 1, the outer products are -8x, the inner products plus 1x. That gives you the -7x in the middle. And then what happens is that the x minus 4's cancel. And remember, when that happens, that means there's a point of discontinuity at x equals 4. That's what happens when the factors cancel. It tells us where our point of discontinuity is. But what we're asked for is where is the vertical asymptote, and that comes from the fact that there's still a factor of x plus 1 on the bottom. Because there's still that x plus 1 on the bottom, our vertical asymptote will be at x equals -1. That's the non-permissive value. Excuse me, so that's why D is the answer. A is saying that you have a vertical asymptote at x equals 4 as well, but that's not true. That's where our point of discontinuity is. It's still a non-permissive value for x. It's still a restriction, but it's not an asymptote. The graph of f at x is shown. What is the range of x equals f at y? X equals f at y is the inverse. And we learned that to get the inverse, we interchange x and y. That's how we do it with the equation, right? For a graph, we take points on the original graph and we switch the x and y values around. X is changed with y. So because of that, the domain of one will be the range of the other and vice versa. X and y's are changed. So the range of the inverse will equal the domain of the original function. The original function has a domain between 0 and 7. That'll be the range of the inverse. So there's no work to show for that. To get the inverse, you switch x and y around. So the domain and ranges are also switched around. The range of the inverse will equal the domain of the original function and vice versa. Use that information for the next question. Simon has the following options to choose from for the new car he plans to purchase. There's 4 different models with 2 different transmissions, 2 interior colors, 5 exterior colors. This is done just using the fundamental counting principle. How many different cars could Simon choose from? It'll be 4 times 2 times 2 times 5. Fundamental counting principle. So you're going to get 8 times 10, which is 80. 80 different cars to choose from. Logging truck license plates in BC begin with AT, followed by 5 digits as shown below. The first digit can be either a 0, 1, 2, or 3, and the remaining digits can be any digit from 0 to 9 inclusive. The number of possible logging trucks that are available in BC is what? Excuse me. So you've only got one choice for the first character. It has to be the letter T. One choice. Then for that second character, it's any 5 digits. I'm sorry, any digit from 0, 1, 2, or 3. So there's 4 choices for that. And then after that, they can be any digit from 0 to 9 inclusive, which means there are 10 choices. 0 is 1, as well as the remaining 9. And unless you're told specifically no repetition, you have to assume that repetition is allowed. So basically it's 4 times 10 to the 4th, which is 40,000. 10 to the 4th is 10,000 times 4. This next numerical response, the number of distinguishable arrangements of all the letters in the word bookworm is what? Well, there are 8 letters there. 8 objects can be arranged in 8 factorial ways. However, there is repetition. There are 3 O's. So it'll be 8 factorial over 3 factorial. Divided by 3 factorial, which is just 6. So there's the answer, 6720. So if this was a numeric response on a diploma, you'd have all 4 boxes filled left to right. Following symbols are selected and arranged to create various code words. No symbol can be repeated in a code word. So there we go, no repetition. Which of the following calculations could be used to determine the number of possible code words that could be created when using at least of the 8 of these symbols selected and arranged? So as soon as you see that word arranged, you know that order matters. So therefore it is a permutation. The word at least means 8 or more. Okay, so again, we know that it's permutations, so we can cross off C and D. Those are combinations. That means order doesn't matter. In this case, it absolutely does. So if you used 8 symbols, well, let's first write down the different scenarios that'll work. You can use 8 symbols or 9 symbols or all 10 symbols. We know that the word or means to add, and that's the difference between A and B. A and B have the same terms. All that's different is that in A they're added, and B they are multiplied. 8 symbols would be 10p8. You're selecting 8 from 10 and order matters. Or means plus, 9 symbols would be 10p9 and then 10p10. Right, so A is the answer, again, because the word or means to add, not multiply. A high school volleyball coach is selecting members for the volleyball team. There are 7 power players, 6 middle, 3 right side, 4 setters trying out for the team and must select the following players. How many ways can the coach select? So in this case, order doesn't matter. Doesn't matter what order you're selected to play a position. If you're selected for that position, you're in that position. Order doesn't matter. So we're going through this package right here at the front. You can grab. So there are 7 power players. 4 need to be selected. So that'll be C7C4. And so now we're going to use times. There are 6 middle players and 3 need to be selected. So that'll be 6C3. And, again, that means times. There are 3 right side and 2 need to be selected. And there are 4 setters and, again, 2 need to be selected. So 7C4, if you do it, you'll get 35. 6C3 is 20. 3C2 is 3. And 4C2 is 6. You multiply those, you'll get 12,600. So 2 important things about this question. Number 1, it's combinations because order doesn't matter. Secondly, you need to multiply the combinations together because it is an and scenario. You're selecting 4 power players and 3 middle and 2 right and 2 setters. Stephanie is going to randomly select 10 songs from the list shown below to create a playlist. Which of the following calculations could be used to determine the number of 10 song playlists that contain 2 or 3 country? So again, the word or means to add. We have 2 scenarios here. That means 2 country and 8 others, or 3 country and 7 others. So that means the 2 country would be selected from the 10 that are there, right? And, it doesn't really say whether order matters or not. And obviously, if you change the order, you get a different playlist. But if you look at the 4 choices, they all involve combinations. So they're telling us that order doesn't matter. You're just creating the playlist. So the 2 country would come from the 10 country songs that are there. So that'll be 10C2. And means times. The 8 others have to come from the songs that are not country, which means the jazz, the classical, and the rock and roll, which is 19. There are 19 songs that are not country, and that's where the other 8 would come from for this first scenario. Again, or means to add. 10 country would be 10C3, and then 7 others would be 19C7. So 10C2 times 19C8 plus 10C3 times 19C7. So I think it's helpful if you kind of write the scenarios out and then looking at it, thinking about it. Is it an and? Is it an or? 2 or 3. It tells us or right there. Right? So we know we're going to have to use addition. Question at the bottom, an executive committee consisting of a president, secretary, and treasurer to be selected from a group of 16 students. So this tells us order matters. If you get selected to be the president, that's not the same as the treasurer or the secretary. So order matters. So from those 16, 3 are selected, order matters, it'll be 16P3, which is 3360. Which of the following graphs could be used to determine the solution to the equation where 3 equals 2 times 5 to the x? So to graph an equation or to solve an equation graphically like this, where you have numbers on both sides of the equals, normally we write two equations. Y equals 3, which is the left side of the equation. The second equation would be y equals 2 times 5 to the x, which is the right side. So this choice, A, doesn't show the line y equals 3, it shows the line y equals 2. And C is the same. It shows the line y equals 2, not the line y equals 3. So now we're down to either B or D as our answer. And that'll be differentiated by the equation y equals 2 times 5 to the x. Grab that booklet there at the front. I also recorded what I did this morning, you guys, and I posted those on Google. No, not the green one, just that one. Yeah. I recorded what I did this morning and it's posted on Google Classroom, okay? So, so which of these graphs, which of these two possibilities shows the graph of 2 times 5 to the x? So what is the y-intercept of that equation? The y-intercept of this is found by letting x equal 0. That might help us distinguish what the right graph is. So that'll be y equals 2 times 5 to the 0. Anything to the 0 is 1, so it's 2 times 1, which is 2. The y-intercept of that graph will be positive 2. If you look at D, it shows a y-intercept of plus 1, not plus 2, which is what graph B shows. So that was the correct answer. We have the right linear and the right exponential graph. Since 2007, Alberta has had an average annual population growth of 2.1% per annum, means per year. The population of Alberta in 2007 was approximately 3,490,000. Assuming the average annual population remains constant, which of the following equations could be used to find the number of years n required for the population to increase to 6,000, which means the number at the end has to be 6,000. So that eliminates A and B, because when we use our exponential growth and decay formula, y is the amount at the end. A is the initial amount. The initial amount would be 3,490,000, which that matches equations C and D. The only difference is what is B the base? That is the growth factor. So if it increases by 2.1%, you're going to have 100% plus 2.1% more. So B as a percent would be 102.1%, but we always have to write it as a decimal. So it'll be 1.021 as a decimal. That is why C is the correct answer. B is the growth rate. The population is increasing at 2.1%, which means you're going to have 100% plus, whoops, I'm sorry, I circled the wrong one. I did. You're going to have 100% plus 2.1% more. Just checking to see if you guys are paying attention. I also got distracted because we didn't have a concert playing out there anymore. So, so number 11 asks to solve that equation. Chances are, if you got something like this on the diploma, it wouldn't be a multiple choice or a numerical response, because they're going to want you to do the work, show the work. But you never know, they might, because you can do this graphically if you want. You can put both equations in and then find the point of intersection. But it can be done also by making the bases the same. I think 9 cubed is 729. Yes, it is. So you can write them both with a base of 9, which is nice because the right side already has a base of 9. You could also write them both with a base of 3. It would just be a bit more work. But on the left side, you got one exponent raised to another, so you multiply the exponents. The bases are the same, so the exponents have to be equal. And then you can solve for x. Subtract the 2x from both sides, add 3 to both sides. X equals 2. And you can always check these. When x is 2, 729 to the power 2 minus 1 will be 1. Obviously, that's 729. The other side, 9 to the power, when x is 2, 2 times 2 is 4, minus 1 is 3. So it checks. Once growing conditions are ideal, the population of a certain bacteria doubles every 20 minutes. Starting from a single bacterium, the number of bacterium E present after m minutes can be modeled by that formula. How long would it take for there to be at least 6,800 bacteria to the nearest minute? So the number at the end has to be 6,800. So again, if this was a numerical response question, you could just do it graphically. You could let y equals 6,800 as your first equation. The second equation would be 2 to the power x over 20. And then find the point of intersection. So second function trace, intersect, enter, enter, enter. So we need to change our windows. That's what that means. So maybe to graph it, I will go zoom 0, zoom fit. Still not quite. We got to make our x max larger to see the graph of 2 to the power m over 20. So let's make our x max larger. Let's make it equal 100 and put a scale of 10. We'll see if that's enough. Not quite. So we'll try again. Let x equal 500 and maybe a scale of 50. There we go. Now we can see the point of intersection. Second function trace, number 5 for intersect, enter, enter, enter. So we get 255 to the nearest minute. So that's solving it graphically, but what if you're asked to do it algebraically? This is where we use logarithms. We can't make the bases the same. So I would convert from exponential to logarithmic. Remember, start with the base and cycle through. So you're starting with the base of 2. That'll be the base of the log. After the 2 comes a 6,800. That's what you're taking, the log base 2 of. And after that becomes the m over 20. That's the last piece. So before we even touch our calculator, we can get the m by itself by multiplying both sides by 20. And so that's what we'll figure out. Whoops. Get off the graph. There we go. 20 times log base 2 of 6,800. So we get the same answer that we got graphically. Like if I just go x equal, that's the last number that's in my calculator, what x equaled from that graph. Exactly the same number. So 255 minutes to the nearest minute. So if this was a numerical response question, that last box would be left blank. Okay? Given log base b of c equals a, which of the following statements must be true? Well, remember, we can't take the log of 0, nor can we take the log of a negative number. And we learned that you can evaluate logarithms with different bases by using the change of base identity. Log base b of c could be written as log c over log b. That means that both c and b have to be greater than 0. We also saw sometimes when you take the log, you can get a negative answer. So c can be negative. Excuse me, a can be negative. So b and c both have to be greater than 0, but c can be, I did it again, a can be greater than 0 or less than 0. So b has to be greater than 0, that's always true, but a doesn't always have to be. It can be less than. You can get a negative answer. Choice B says that both b and c have to be greater than 0. Well, we know that's correct. The reason C is not correct is because A will not always be greater than 0. And the reason D is not always correct is because A will not always be greater than B. In fact, B has to be positive, but you can get a negative answer for A. You can get an answer from a log that is negative. For example, if you just took the log of, I don't know, let's say the log of 5. That's a decimal. Log of 1/5. That's a negative value. That's saying 10 to what power is 1/5? The answer is negative 0.69897, etc. So you can get a negative answer for a log. So B was the answer there. Which of the following is equivalent to y equals 3 to the x? Notice that all 4 choices involve logarithms, so let's write this as a logarithm by starting with the base and cycling through. The base of the log will be the same as the base of the exponential function, base 3. After that comes the y. After that comes the x. So x equals log base 3 of y. Easy mark. You're going to have to change from logarithmic to exponential and probably exponential to logarithm on the exam. Okay, so should know how to do that by now. It's going to be on there. Number 5. When that is simplified into a single log, what is the value excuse me, of a, which is the argument? So before we can combine these two, which we can because there's a minus sign in between and the bases are the same, we can use the quotient law to combine them. But first we need to get rid of the coefficient of 3. This will be log base 6 of 40 minus log base 6 of 2 cubed, or log base 6 of 40 minus log base 6 of 8, because 2 cubed is 8. So now we'll use the quotient law to combine. It'll be log base 6 of 40 over 8, and 40 divided by 8 is 5. So there's the value of A. And you could check this on your calculator. If you find the value of the original expression, log base 6 of 40 minus 3 times the log base 6 of 2, it's that value. Well, when we put log base 6 of 5 in, we should get the same number. And you do. So the answer we got is correct. It equals what we started with. So in this case here, that first box would be filled in, everything else would be blank. Sunrise for a particular Alberta city can be modeled by that sinusoidal regression function, where S is the sunrise in hours after midnight, and D is the number of days since the beginning of the year. According to this function, the sunrise on August 15th, which is day 227, to the nearest hundredth of an hour is how many hours after midnight? So you're just going to let D equal 227. And you can do this in your calculator. You just have to make sure that you are in radian mode. Whenever you're using these sinusoidal equations, you're almost always in radians unless you're specifically told that the variable is in degrees. If you're not told that, which obviously in this case here, the variable D is day number, you're in radians. And you can just put that equation in the calculator. 1.51 times the sine of, we're going to have 0.0172 times D, which is 227, yeah, plus the 1.51, right? These are all in the brackets after sine, so you're going to take the sine of that number once it is calculated. And then outside the bracket, you have the plus 7. So to the nearest hundredth of an hour, it'll be 5.85 hours after midnight. And remember, there is a spot in the numerical response for a decimal. It's either in column 2 or column 3. In this case, it would be in column 2, and there's a place where you actually bubble in the decimal at the top. But there will only be a decimal in column 1 or column 2. Number 14, an equation of a particular cubic function written in that form where m, n, and p are different whole numbers. Which of the following could be the graph of this polynomial function? So because they're different factors, you're going to have 3 different x-intercepts, which all of our graphs do. So that doesn't help us. However, if you look at the first 2 factors, it's x minus m and x minus n. This means you're going to have an x-intercept of positive m, an x-intercept of positive n, and the last factor would be an x-intercept of negative p. So the graph we're looking for is the graph that has 2 x-intercepts that are positive and 1 intercept that is negative. So that eliminates that one and that one. The other 2 have 2 positive x-intercepts and 1 negative. What's different about them is their end behavior. C falls to the left and rises to the right, which means that the initial term coefficient would have to be positive. Whereas D rises left and falls right. The initial term coefficient there would have to be negative. Just like a negative slope on a line rises left and falls right. So if we look back at our equation, there is no negative sign in front of the brackets anywhere, which means our initial term coefficient would be positive. So C is the correct answer. It has to fall to the left, rise to the right, just like a line with a positive slope. To model the percentage of the surface of the moon that will be visible from Alberta in January 2016, a student graph the regression function shown below. So you can see along the bottom, we have the days after January 1, and along the side, the percentage of the surface that's visible. To predict when the surface of the moon will not be visible, the student used the graph to shown above and determined, well, that would be the x-intercept. When the surface of the moon is not visible, that means 0% is visible. So you're looking where y is 0. That's the x-intercept. And it doesn't ask you just for the value of that. It asks what characteristic are you looking for. So it is an x-intercept. Two pendulums are shown below and are allowed to complete one swing. So they both have the same angle from vertical that they swing, 10 degrees, but pendulum 2 has a longer radius than pendulum 1. The number of degrees the pendulum swings from vertical is measured at regular time intervals and recorded. The number of degrees to the right of the vertical is recorded as positive. If it's left, it's recorded as negative. So these two show angles to the right, that's why they're positive. The graph representing the degrees from vertical as a function of time t in seconds for each pendulum is shown. So there's your two graphs. The sinusoidal functions representing the two pendulums, they differ in what characteristic? And the answer to that would be the period, because the period is how long it takes to go through one cycle. The first pendulum goes through the cycle, looks like in 1.2 seconds, where the second one, it's something greater than 1.5 seconds. They have the same amplitude. They go up to the same max, down to the same min. They have the same median value because they have the same max and min. The median value is the middle value. That's our D value. Looks like it's the T axis. And they have the same maximum value. They differ in period because it takes one longer to go through one cycle than the other. So, I mean, sometimes you see a question like that where you got all these diagrams and graphs and all these words. Really not hard question at all. So don't get distracted by if you have to do a bit of reading. Okay, the graphs of those two functions are shown. Each function is then vertically stretched by a factor of 2 about the x-axis, reflected in the y-axis, resulting in the new functions p and q respectively. The domain and range of each of the new functions are found in the table below. So which numbers will give us the domain and range of the new functions? So let's look at the original one, looking at f. If you vertically stretch it by a factor of 2 about the x-axis, that's not going to change the domain or the range. Okay, normally a vertical stretch might change the range, but in this case it wouldn't. Because this graph starts at the point 2, 0, a y value of 0. Multiplying that by a stretch factor of 2 won't change. And it just keeps going up and up and up. Vertically stretching that will just make it go up higher quicker, but it'll still go up, 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 and up. So the range of this has not changed. So let's write that down. Range of this function will stay from 0 to positive infinity. If, though, this graph is reflected in the y-axis, now it's going to be going downwards instead of upwards. Just hang on a second. I needed to read it again. And reflected in the y-axis, sorry. If it's reflected in the y-axis, then instead of going from -2 and going upwards and to the right, it's going to go from +2 and then go upwards to the left. So it's going to go something like this. I'm vertically stretching it by 2 and then reflecting it over the y-axis. So now the domain will change. The domain will go from -infinity to +2. Now, what about the graph of Q? If you vertically stretch it by a factor of 2 about the x-axis, that's going to change this point here. Instead of starting at -2, -4, it's actually going to start at -2, -8 is where it's going to start at. So that will be how we determine our range. The range will go from -8 up to positive infinity. When you reflect this over the x-axis, or the y-axis, I should say. So sure, this point would go over here. It would now be at positive 2, negative 8, but it still goes left and right forever. So the domain will not change. It'll still go from negative infinity to positive infinity. What do you guys need? Come on in. Sorry? She's actually told me that she doesn't really like you and she wants you to leave her alone. You make her very uncomfortable. Very. Okay, so the domain and range of each new function are found in the table below. So the table below the first graph will be our possible, or I should say, the domain and range of the new function of p. So for p, which is connected to f, the domain is greater than between negative infinity and 2, and the range is from 0 to positive infinity. So the possible domain would be that x is less than or equal to 2. So that is 1. The range of this graph is that y is greater than equal to 0. So that is 5. For q, the domain is all real numbers, which is number 2 in that list. And the range of that graph is y is greater than or equal to negative 8, which is 6 in that list. So the code would be 1526, and you'd have all 4 boxes filled up. Number 17, the graph of f at x is transformed to negative f at negative 2x. What's the equation? So first thing, when a is negative 1, remember it's a times f at x. The entire function gets multiplied by negative 1. So just to illustrate that, we'll put it all in brackets, and that's going to make both signs change. So it'll look like that. Secondly, when we have a b value of negative 2, if we talk about the transformations, that'll be reflection over the y-axis as well as a horizontal stretch by a half. Remember, the horizontal stretch and b are reciprocals of each other. But when you're writing the graph, you just replace x with negative 2x. And whatever happened to the x happens to the negative 2x as well. So you're going to have negative 2, x is replaced with negative 2x. Whatever happened to the x before, which is squared, happens to the negative 2x. So this is going to give us negative 2 times 4x squared, take away 3, or negative 8x squared, take away 3. So that's why B was the answer. And I wrote these as F, and it should have been G. But that's where it comes from. Student is asked to draw the inverse of each of the following graphs. If no additional restrictions are given, which will have the most y-intercepts? Well, remember that to do an inverse, you interchange x and y. The y-intercept of the inverse will come from the x-intercepts of the original function. So the graph with the highest number of x-intercepts will be the one whose inverse has the highest number of y-intercepts, which is graph 2. Yeah? Number 8. We've got those two logarithmic equations. What is the value of log base a of b plus log base b of a? So you're told that log base a of 64 is 2. Let's find out what a is. And we can do that by taking this expression and changing it from logarithmic to exponential. Start with the base and cycle through. You'll get a squared equals 64. Take the square root of both sides, and a will equal 8. So there's our value of a. It's 8. Taking that second expression, let's find out what b is. So I've got 2 log base 8 of b equals 4/3. I would first divide both sides by 2, which is the same as multiplying by a half. So that's going to give you 4/6, or 2/3, when you multiply by a half. And then if we convert from logarithmic to exponential, start with the base and cycle through, it'll be 8 to the 2/3 equals b. And 8 to the 2/3 can be evaluated because power 2/3 means cube root squared. The cube root of 8 is 2, and 2 squared is 4. So there's our b value. And we are asked to find what log base a of b plus log base b of a equals. So it'll be log base 8 of 4 plus log base 4 of 8. And we can evaluate these on our calculator. Log base 8 of 4 is a rational number, actually 2/3. Let me store that into memory. Log base 4 of 8 is that decimal when we add them together to the nearest hundredth, 2.17. So this is 2/3 plus 3/2, which again, 2.17 rounded to the nearest hundredth. Number 19, the graph of f at x is shown below. It's transformed to y equals the root of f at x. How many invariant points are there? Well, remember, the invariant points come where y equals 0. So there's 1 there and 1 there where y equals 0. So now we have 2. But also where y equals +1, which is there, there, and there. So there would be a total of 5 invariant points. The invariant points come where y is 0 or where y is 1. There's 2 places where y is 0 and 3 where y is 1. Use the following information to answer the next. H at x equals g at x minus GOF at x. You're given g and f. What is the value of h at 2? So that will be g at 2 minus g at f at 2. G at +2. So using the g at x function, it'll be 3 times 2 squared minus 2. 3 times 4 is 12. Minus 2 is 10. Minus g at f at 2. So using the f at x function, it'll be 2 over 2 plus 5. Which is 2 over 7. So now we have to find out what g at 2/7 is. So again, using the g at x function, it'll be 3 times 2/7 all squared minus 2 over 7 2/7 all squared is 4 over 49 times 3 is 12 over 49 minus 14 over 49, which is negative 2 over 49. The minus minus becomes a plus positive, so it'll be 10 plus 2 over 49. So 2 divided by 49 plus 10. It does ask us to round to the nearest tenth, so that would just be 10.0, rounded to the nearest tenth. Unit circle shown below with an angle theta in standard position, the point k, comma, 0.8, which means you're going to go k units to the left, 0.8 up. And because it's a unit circle, remember that means the radius is 1. What is the value of k, as well as what is the cosecant of theta? So using Pythagorean theorem, we'll find k. K squared plus 0.8 squared equals 1 squared. K squared will be 1, take away 0.8 squared, which is 0.64. So k squared will equal 0.36, and k will equal 0.6, which would be 3/5. But again, it's negative because you're going left from the origin. So that eliminates A and B as possible answers. So we also want to state the value of the cosecant. So K is negative 0.6. The cosecant is the reciprocal of sine. The sine of theta would be opposite over hypotenuse, 0.8 over 1. So the cosecant would be the reciprocal, 1 over 0.8. And then, both answers that we have to choose from are fractions, but we can use our calculator to find out what 1 divided by 0.8 is. 1.25, which is 5/4. And it is positive because of what quadrant we're in. The opposite and the hypotenuse are both positive, so the ratio is positive. General solution to that equation is what? Well, from the unit circle, if the cosine is √3 over 2, that means our reference angle is 30 degrees. Now, all of these have reference angles of 30 degrees. However, the fact that the cosine is negative tells us that we have to be in quadrants 2 and 3, which is why B is the correct answer. A uses quadrant 1, cosine isn't negative there. C uses quadrant 4, cosine isn't negative there. D does use quadrant 3, or 2, but it misses quadrant 3. So that's why it's not correct. So number 22, we basically want to solve that equation. So the issue here is that you've got two different trig functions represented. You've got sine squared x and cosine x. So to do this, you would replace sine squared x with 1 minus cos squared x. That comes from that Pythagorean identity. And so we need to simplify this equation to solve it. I'll move everything over to the right side to make the 2 cos squared x positive. I'm going to add cos x as well to both sides. On the left side, 2 minus 1 is 1. It's a positive 1 on the left, which will make it a negative 1 on the right. So we want to solve this by factoring. And I'll have to be a plus 1 there and a minus 1 there, so we get our positive 1 cos x in the middle. Our solutions will come when each factor equals 0. And the cosine of x equals positive 1/2 in the first quadrant at pi on 3. So that eliminates that one and that one. It also equals positive 1/2 in the fourth quadrant, and that would be at 5 pi on 3. It equals negative 1 at pi, so that confirms that B is correct. Number 23. What is that expression equivalent to? Well, it's sine times secant, and secant is 1 over cos, and that is divided by cotan, which is cos over sine. We divide fractions by multiplying by the reciprocal, which gives us sine squared x over cos squared x, and that is tan squared x. So that eliminates A and B. So it comes down to what the restrictions are. And the restrictions here are that it cannot equal any multiple of pi on 2. Because cosine can't equal 0, neither can sine equal 0. So that's why it's every multiple of pi on 2. Number 24, the range of that sinusoidal graph is what? Well, we learned that the maximum was found by taking the absolute value of d and adding a. The minimum was found by taking, I'm sorry, not the absolute value of d, just d. I apologize for that. The minimum was d, take away a. You see, d is a horizontal midline. It's your median value. It's the a part that should be the absolute value of, which in this case doesn't matter because a is just k. So the maximum will be negative 3 plus k. The minimum will be negative 3 minus k. So this is why D is the correct answer for the range. Number 25 says the secant is positive 5/4. Using our cast rule, there are only 2 quadrants where cosine is positive. If the secant is positive, the cosine is as well. However, we're also looking to where sine is negative, which means we have to be in the 4th quadrant. That's the only quadrant where cosine is positive, which means secant is positive and sine is negative. Question wants us to state what cotan of theta is equal to. So theta, the angle between the terminal arm and the x-axis. The secant is 5/4. So the cosine of theta will be 4/5, the reciprocal, and cosine is adjacent over hypotenuse. By Pythagorean theorem, you could find the length of the third side, it would be negative 2. This is a 3, 4, 5 triangle. And it's negative because you're going downwards. Cotan is cos over sine, or in this case here, the reciprocal of tangent. The tangent is negative 3 over 4, so the cotan would be 4 over negative 3, negative 4/3. Number 26, you want to find what log base 6 of x is. So you have to first figure out what x is. And to do that, we can take this, convert it to exponential. It'll be 6 to the power 5 equals x cubed over 8. So x cubed will equal 8 times 6 to the power 5. X cubed equals that large number, 62,208. And then we'll take the cube root of that to get what x is. So it's a decimal, approximately 39.6. But I'm going to keep it in my calculator for this next step, because now we want to find log base 6 of that 39.6. Log base 6 of the previous answer to the nearest tenth, 2.1. To the nearest tenth. Number 27. You've got p at x, not complete though because you got the minus k. And then you've got a second version of that where it's x plus 3 times that quadratic. So what are the values of a, b, and c respectively? So the first thing we can do is, excuse me, we can find out what k is. If x plus 3 is a factor, that means p at negative 3 has to equal 0. This is remainder theorem. So this will allow us to find out what k is. 2 times negative 3 all cubed plus 13 times negative 2 all squared plus 20 times negative 2 minus, sorry, I don't know why I changed from 3 to 2. Minus k equals 0. So negative 3 all cubed is negative 27 times 2 is negative 54. Negative 3 all squared is positive 9 times 13 would be 117, I think. Minus 60 minus k equals 0. So negative 54 plus 117 minus 60. So 3 minus k equals 0. So k equals 3. So if we actually divided p at x by x plus 3, then with our correct k value in there, we'll get the quadratic that's left. That'll be the coefficients at the bottom. But instead of dividing by x plus 3, we normally change to x minus 3 so we could add as we went along. So we multiply and add. Multiply and add. Multiply, add, we get our remainder of 0. And these are the answers. You want the values of a, b, and c respectively? 271. So here's one you see where they put the minus sign in front of the c. So you just want the 1. 3 digits, so that last box will be left blank. Okay. So for f at x equals that expression, so So A is a positive value, B is a positive value, and C is a positive value. What is the range? So normally for a radical function, it starts at 0, 0, and it goes upwards and to the right. That's the graph of the square root function. But in this case, the negative sign in front means it's reflected over the x-axis, and now it's going to go downwards forever. So without that plus c on the end, it would start at 0, 0 and go downwards. This part inside might shift it over a little bit, one way or the other, but that doesn't change the range. But when you go up c units, that will change the range. It's going to start at a y value of c and go downwards forever. So the range would be y must be less than or equal to c. That is the range for that expression. Normally, a radical function starts at 0, 0 and goes upwards and to the right. This one is reflected over the x-axis, so now it's going to go downwards and to the right. And then shift it up c units, it's going to start at y equals c and go downwards and to the right. Number 29, we want the exact value of that expression, so we can use the unit circle. The cosecant of pi on 2, well, cosecant is a reciprocal of sine. At pi on 2, the coordinates there are 0, 1. The sine is 1, or 1 over 1. Well, the cosecant will be also 1 over 1, plus the secant of 2 pi on 3. So that's connected to the cosine of 2 pi on 3. The cosine of 2 pi on 3 is 1/2. Actually, pi on 3 is 1/2. The cosine in quadrant 2 is negative 1/2. That's the cosine, but we want the reciprocal of that. The reciprocal of negative 1/2 is negative 2 over 1. Minus the sine of pi on 4, which is root 2 over 2. So we need to add these together, get a common denominator. It'll be 2 minus 2 minus, no, minus 4, excuse me. Minus 4 minus root 2. Or negative 2 minus root 2 all over 2. And that could also be written as 2 plus root 2 over negative 2. And this is one that you could check in your calculator. With our calculator in radian mode, 1 divided by the sine of pi on 2 plus, I'm going to use brackets here, 1 divided by the cosine of 2 pi on 3 minus the sine of pi on 4. Is that decimal? So if I check my answer, 2 plus the root of 2 in brackets divided by negative 2, same decimal. So our answer is correct. It's just an exact value. If tan theta equals negative 2.6 and we're in quadrant 4, what is the value of theta? So this is just solving a trig equation, but in this case, we can't use the unit circle because nowhere on the unit circle does the tangent equal 2.6. But we're told that we're in the 4th quadrant. And that's why it's negative. At that point, the negative sign has done its job. To find the reference angle theta, in this case, we need to be in degrees and go second function tan of positive 2.6. Again, the negative sign has done its job. It helps us determine which quadrant we're in, even though we're told that we're in the 4th quadrant. So, in degree mode, second function tan of 2.6. To the nearest degree, that would be 69 degrees. And then the rotation angle would be 69 degrees short of 360. Which is 291, excuse me, 291. So there it is to the nearest degree. Number 31, we want to find the value of m for that expression. Before we start, though, I would take that second term and write it as 2x to the negative 1. The fifth term is 560x to the 8th. Remember the general term formula, it's on the formula sheet. Also remember that the value of k is 1 less than the term number. So in this case here, k will be 4. So 560x to the 8th will equal 7c4 x to the m to the power 7 minus 4. We're going to have negative 2 to the power 4, as well as x to the negative 1 to the power 4. We need to solve for m. So 7c4 times 16, that's negative 2 to the 4th, actually gives us our 560. So they're going to cancel. We're going to have x to the 3m. 7 minus 4 is 3, so that'll be 3m times x to the negative 4. So again, the 560s cancel, and we'll have x to the 8th equals x to the 3m minus 4. Those last two factors can be combined. You're multiplying powers with the same base, so you add the exponents and you keep the base the same. So now the bases are equal, the exponents will be equal as well. We can say that 8 equals 3m minus 4. 3m will equal 12, and m will equal 4. So there it is. We're looking for the fifth term, and the fifth term is where k is 4. So you're looking at this last part. Because it is negative 2 times x to the negative 1. If you look over here, it's negative 2 times x to the negative 1. So they're multiplied here, so they're going to stay multiplied over here. Different arrangements of the word, letters of the word mathematics that start with an M and ends with a C. Well, there are two choices for the first letter, one choice for the last letter. There were 11 to begin with, so now you have 9 left, 9 factorial ways of that happening, but there's repetition. There are 2 M's, there are 2 A's, and there are 2 T's. So you have to deal with the repetition. So you can cancel the 2 on top with one of the 2 factorials on the bottom because 2 factorial is 2. And then our answer will be 9 factorial over 4. 90,720. There's the answer.